can guarantee that the channel is loop-free tree structure. Channel pruning algorithms. Channels in this flavor of Textella, as I alluded to before, the red flavor, are considered to be multicast channels in the sense that they do not exist globally across the network fabric. However, they're allowed to. If you've got people on every server and they're all on the same channel, there's nothing that prevents it, but there's nothing that forces it, which is important. Pruning code is executed when a node is removed from the channel's node chain. This code ensures that there is never a stale branch off to a server where it's no longer needed. Basically, the idea is every time you see a socket from a channel leave, you run a test on the channel, and you say, is this channel only one server? And if it is, kill it, because you're a branch off to nowhere. If you were doing anything useful, you would have had users or other servers connected to you, being that you were either providing traffic to a user or acting as a transit server, passing traffic through you. So we'll start with some more synchronization here. I'll show you a third one. Okay. Let's pick a channel here. Let's try 39. As you can see, we got a whole bunch more query hits this time. It's because there's a lot more paths to the channel, because it's not a dot on the network anymore. It's a line on the network. It's a bunch of servers. So there's a whole bunch of paths. So we'll pick one at random here. We'll try this one. Looks good. Open up a circuit link to it. Pretty much what the user sees. It's self-joined with ops, topic, blah, blah, blah. It lost its ops. Remorse came in with ops, and RMRS came in with no ops. So as you can see, the channel is still synchronized, with only Remorse having ops. Take a look at that from all the other ones too. Panoramic. Also got who working, so you can do that. They're identical to the IRC commands pretty much. And let's take a look at the synchronization sequence that's going on there. Let's take a look at the links of the channel here. It's important to keep in mind that IRC networks, the entire network has a links, a tree-structured links like this. Every channel on Textella has its own links. So every channel could be going in different directions, moving however it wants to over the mesh. It doesn't make any they're independent of each other. You can almost think of them as little virtual IRC networks on top of this mesh. Anyway, let's see what we got here. We got 1134 with Remorse on it. 1135 is connected to 1134. 1137 is connected to 1135. 1154 is connected to 1137. You got Remorse hanging off that. 1152 is hanging off 1137, 36 to 35, blah, 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 blah. Let's take a look at one of these servers. We'll take a look at 1136 because it's transiting traffic. Where is my debug here? 36. No. Okay. All right, let's try to go through this synchronization sequence because it looks kind of long and interesting, and it'll give me something to talk about, right? First thing this server sees is a circuit link coming in. That's referring to a query hit that passed through it earlier. Server 1140 introduces itself. Then it says that it has 1139 connected to it. Then it says it has Remorse 04 hanging off 1139, timestamp, blah, blah, blah. Topic, okay. SIGA live in. to cap off the sequence. A circuit override is sent back. The server is announcing itself, 1136. Circuit live out caps off that sequence. The next thing it does is it turns around and it begins forward propagation again. The circuit link, you can see with the same descriptor ID, #havoc, there's your timestamp. It announces that it itself is named 1136. It has 1140 connected to 1136, 1139 connected to 1140, and remorse hanging off that, and the topic. Come down a little bit. The next thing we receive is a circuit override from our neighboring server that we just propagated to. Where was it? Did I just lose my place? Here we go, right? It's announcing that its name is 1152, and that's it, not too much interesting. The circuit is then said to be set up there. So we start seeing merge-ins coming in because the channel is still being built outward, but there's no need to actually do any binding or circuit things or anything like that related to the local server. So we see a merge-in come. 1152 is hanging off 1136. See the topics. Okay. We see another merge-in. 1137 hooked off 1132, blah, 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 blah. Now, let's take a look at this graph again and see what the channel looks like now. And that takes a little while. Okay, that one's done. Well, while we're going, I'll start talking about some interesting bugs discovered in development. Inherent broadcast propagation problems occur under certain memory constrictions. The Nutella broadcast theory has within it a fundamental flaw. Servers cannot remember an infinite amount of broadcast identifiers. They must eventually be queued out or timed out. A broadcast, this is going to sound a little weird. If a broadcast can survive in the network fabric long enough to loop back to its originator after the broadcast identifier has been forgotten, the poisoning mechanism that drives the broadcast outward is then defeated. Once this occurs, the only thing that prevents infinite regeneration of that broadcast is the time-to-live mechanism. The segment of the network is crippled under its own DOS attack for the life of the broadcast. This sounds like a bug that you would never run into. I ran into this bug. Basically, I was testing sendQ code. I wrote internal buffering for sending whatever to clients or neighbors, and I wanted to test it out. So I figured the best way to test it would just be to send as many broadcasts as I can, because broadcasts generate a lot of traffic back to you. Anyway, I dropped megs and megs and megs of broadcasts, and the send queue slowly filled up, as it should, because my client could not keep up with it. And when you hit whatever the ceiling of the send queue is, it's configurable, it's in the configuration file. You got to kill the client. So the client dies, and I still had a whole lot of traffic coming back destined for that client, because the only server on the network that was aware that that client was dead was the local server that it was connected to. So I thought it would be a good idea to make a command that propagated outward when the client died, that basically said, kill the path, back to the client. And that's when I ran into the bug. Pretty much what happened was you get a whole series of broadcasts that were spreading outward. The client send queue filled up. The server killed all the broadcasts that were associated with that client and started sending out a broadcast that was chasing the previous broadcasts that were spreading through the mesh. the first broadcast that the client sent out came back to the original server, and because the server already killed it, it thought it was a new broadcast. So it grabbed it, it remembered it, and it propagated it to its servers, all its neighboring servers. And since that the command that was used to tear down that path, that broadcast path, was also broadcasted to all the neighbors did the same thing. So the network basically DOSed itself to death. It eventually stopped after about a half an hour, and this is with a time to live of 8. All right, not a huge time to live, but without that poisoning mechanism that keeps broadcasts from spreading around, and you have a network that looks like this, it's a lot of regeneration. Anyway, what I ended up having to do was basically say, keep the broadcast identifier in memory, but forget where it was coming from. Anyway, take a look at this channel here. We got remorse connected to 1154. That goes over to this server. All right, can I see that? Okay. This server right here, if you zoom in, you can see it's kind of a transit server. It's got multiple connections to it, but it still maintains a tree structure. 1137 follows over to this guy over here. 1135, which is connected to 1134, which is connected to remorse. Oops, wrong way. And then you can see a whole mess of connections in here. This one goes there, that one goes there, that one goes there, over to the other client over here. And the leg bone is connected to the hip bone, blah, 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 blah. Anyway, let's talk about the consequences of the absence of global network visibility. Scalability comes at a price. The price is the absence of global network visibility, basically. Collision domains for nicknames and server names have been localized to the channel, not the network. This means that a remorse on pound havoc can be a totally different remorse than one that's on pound Textella. A server a user is connected to is the only server that is aware of all the channels that the user is on. That means if you want to whois somebody and have that work properly, all whoises have to be remote whoises, because only the server that you're connected to is aware of all the channels that you're on. Well, let's see what else we got. Well, that's more or less it. I mean, does anybody have any questions, first of all? Is there comments or anything? No? Yes, Ian.
For this, besides IRC, like perhaps...
That's a very good question.
Can you repeat the question?
Excuse me?
Repeat his question, please.
Repeat his question? It wants to know what's the point.
Is it just for chat? And no, it's not just for chat. This is basically a testing protocol. I wanted to make sure that the signaling system worked. What I'm basically trying to do is make a binary, scalable version of IRC so you can drop things like